Think about the biggest names in tech history. Who comes to mind? Most likely, you're thinking of the founding fathers of the digital age, Steve Jobs, Bill Gates, maybe Alan Turing. Their names dominate our collective memory. But there is a fundamental truth that this narrative obscures. The intellectual and technical foundations of the device you are using right now were laid by women. We're talking about the inventors of wireless communication, the mathematicians who guided NASA to the moon, and the pioneers who turned machine code into the languages we speak today. Today, we are going to look at 4 women, Hedy Lamarr, Evelyn Boyd Granville, Grace Hopper, and Sister Mary Kenneth Keller, whose work was not just tangential to tech history, it was central to it. Every time you use Bluetooth or Wi-Fi, you are using a system developed by a 1940s actress. Every time a rocket enters orbit, it follows trajectories calculated by a black woman whose name was nearly erased from the records. This is the paradox of invisibility. Why do we use these innovations every day, yet remain completely unaware of the women who built them? Let's dive into the ghost in the machine and recover the true lineage of the digital age. Before we meet these innovators, we have to ask a difficult question. How did they become invisible in the first place? It wasn't an accident. It was the result of systemic attribution gaps and institutional practices. First, there's the mythology of the solitary genius. We love stories about a single man having a eureka moment. But innovation is collaborative. When women worked on teams, their work was often absorbed into the narrative of the male leader. If they worked alone, they were often dismissed as anomalies. There is also a massive irony here. In the early days of computing during World War II, programming was actually seen as women's work. Women were the computers who did the heavy mathematical lifting. But as computing became prestigious and profitable, it was professionalized. Women were pushed out through educational barriers and hiring discrimination. The field was deliberately reframed as masculine. The gender imbalance we see in tech today isn't natural or inevitable. It's the result of historical decisions to exclude the very people who started the field.
Let's start with a name you might know from the silver screen, Hedy Lamarr.
History remembers her as a Hollywood star, but she was also a talented mathematician. In 1942, while the world was at war, she teamed up with composer George Antheil to solve a military problem. Radio signals for torpedoes were too easy to jam. Their solution was brilliant: frequency hopping. Instead of sending a signal on one frequency, the system would rapidly switch between frequencies in a secret pattern. It made interception nearly impossible. They even used a mechanism inspired by player piano rolls to coordinate the switches. They were granted U.S. Patent 2,292,387 in 1947, but the Navy told her she should go sell war bonds instead of playing with inventions. Her patent expired in 1959 without her making a cent. But here is why Hedy Lamarr is in your pocket right now. When digital tech finally caught up to her idea decades later, frequency hopping spread spectrum became the backbone of Bluetooth, which cycles through 79 frequencies 1,600 times per second, exactly as Lamarr envisioned. Wi-Fi security, ensuring your data stays private. Cellular networks, which use variants of her framework to manage millions of calls. In 2014, her work was finally recognized as one of the most important technologies of the century. Yet, how many people using Bluetooth today think of a 1940s actress? Her case is the perfect example of how gendered expectations, the idea that an actress couldn't understand math, erased a foundational innovator from the books. Next, we meet Evelyn Boyd Granville. Born in 1924, Granville was a mathematical prodigy. She earned her Ph.D. from Yale in 1949, making her one of the very first Black women to earn a doctorate in mathematics in the U.S. Because of the era's segregation and sexism, she couldn't get an academic job. So, she went to work for the U.S. Navy and eventually IBM and NASA. At NASA, Granville worked on orbital mechanics and trajectory analysis. If you look at the successful missions of the space race, the Apollo missions, the Vanguard program, the Mercury missions, they all relied on her computational verification. She solved the differential equations that defined how a satellite stays in orbit. She was the human computer ensuring the astronauts actually made it back. But her work was institutionally invisible. She produced the tables and the math, but the fame went to the astronauts and the male directors. Her contribution was treated as technical support rather than intellectual contribution. Granville lived until 2023. She eventually received the Wilbur Cross Medal from Yale, and the Department of Energy finally recognized her in 2024. But for most of her life, the mathematician who mapped the stars was kept in the shadows of the rockets she helped launch. Now, let's talk about the woman who actually made coding a thing, Rear Admiral Grace Hopper. In the 1940s, computers like the Mark I were the size of rooms. To program them, you had to write in machine code, just strings of numbers that the hardware understood. It was incredibly slow and required deep engineering knowledge.
Hopper asked a revolutionary question. Why can't we just talk to the computer in English?
She invented the compiler. This is a program that translates human-readable code into machine instructions. It sounds simple now, but in the 1950s, people thought it was impossible. Hopper's work led to COBOL, a programming language that looks like English. Instead of cryptic numbers, you could write, "Move total sales to monthly report." This democratized programming. You didn't need to be an electrical engineer to write software anymore. Today, every line of code in Python, Java, or C++ depends on the abstraction layer concept that Grace Hopper pioneered. Billions of lines of COBOL are still running in our banking and government systems today. While she was recognized in the Navy, her individual role as the originator of these concepts often gets submerged in narratives about the institutions she worked for. We use her translator every single day, often without realizing she was the one who taught computers how to speak our language. Finally, we have perhaps the most unexpected pioneer, Sister Mary Kenneth Keller. In 1965, she became the first American woman to earn a Ph.D. in computer science. Yes, she was a nun. Historically, religious orders were one of the few places women could pursue high-level scholarship without being forced into domestic life. Keller used that space to help develop ALGOL, one of the most influential programming languages of the 60s. If you've ever heard of recursion or block structures in coding, those are concepts Keller helped formalize. But her biggest impact was institutional. She established the computer science program at Clark University in 1966. This was one of the first times computer science was taught as its own discipline, separate from math or engineering. She was a massive advocate for making tech accessible to women and diverse students. She saw the digital age coming and wanted to make sure everyone had a seat at the table. For decades after her death, she was rarely mentioned in textbooks. But without her, computer science might not even be an academic major today. So, why does this history matter? Is it just about fixing the record? No, it's about the future. Right now, women only make up about 25% of computing professionals. In some Ph.D. programs, it's less than 10%. When we tell a version of tech history that only features men, we tell young women that they don't belong here. We create a self-reinforcing cycle where women's contributions are less documented, so they seem less significant, so we don't look for them in the future. Inaccurate history is bad science. If we don't understand who actually invented our tools, we don't understand how innovation works. There are movements today working to digitize archives and rewrite the curricula to include Hopper, Granville, Lamarr, and Keller. But the responsibility to know falls on us. The next time you use Bluetooth, remember Hedy Lamarr. The next time you write a line of code, remember Grace Hopper. Women didn't just join the tech revolution late, they were the ones who started it. And it's time we stopped treating them like ghosts in the machine. If you found this helpful, share it with someone who loves tech. Let's make sure these names aren't forgotten again. I'll see you in the next one.